Today is the era of data-driven decision-making. Organizations are gradually but definitely realizing that data has value attached to it. There's voluminous amounts of data involved in running a business, which needs to be analyzed effectively and efficiently. So to analyze this voluminous data, the storage and processing systems need to be fundamentally impeccable. Hi all, this is Upasna from Edureka, and today we are going to talk about the skills required to become a big data engineer. So before we begin, let's talk about the agenda for today. First up, we're going to be talking about who is a big data engineer, followed by a few of his responsibilities. Then we are going to be talking about the focus of this session, which is big data engineer skills. And finally, we're going to talk about how to acquire those required skills. So without much ado, let's get straight into the module. But who is a big data engineer? Now, a data engineer is the one who takes care of a complete data pipeline, including the storage and processing systems. A data engineer builds the foundation for all data processing and analytics activities. They build a pipeline for data collection and a storage and funnel the data to the data analyst and scientists. The most crucial role of a big data engineer is to design, develop, construct, install, test, and maintain the complete data management and processing systems. They are the ones who handle the complete infrastructure for data management and processing. Now, to find out the responsibilities of a data engineer, we are going to be looking at some job descriptions for which we have picked out 3 companies that you have definitely heard of. First of all, we have Dell. Now, the job description here says a big data engineer needs to structure large data sets by applying standard data modeling and statistical techniques, collect and transform unstructured data with self-serving capabilities for less technical analytics, and identify gaps in the data processes and drive improvement loops. He also needs to know how to perform ETL processes using scripting languages and tools, and develop and maintain self-service capabilities for business KPI drill-down needs. Apart from which, they need to know how to set up development principles and delivery standards. Teamwork spirit and to enable a part of a global team with remote leaders and peers is also an added bonus. Next, we are going to be seeing the job description of Ericsson. Now, as far as I notice, it's a pretty straightforward job description. You need to have new ideas of machine learning applications, understand the necessary data requirements to implement the same machine learning applications, deploy machine learning solutions into production while optimizing solutions for performance and scalability. Plus, it says you need to know the fundamentals of data engineering, which is further gone down to explain that data engineering from their perspective is basically ensuring a good data flow between databases and backend systems. Next, we have Walmart's description of a big data engineer. They've kept it pretty simple as well. They say they need somebody that can design, build, test, and deploy cutting-edge solutions at scale while deploying and monitoring products on a cloud platform. They also need somebody that can interact with Walmart engineering teams across geographies to leverage expertise and contribute to the tech community. Apart from which, they need data engineers that can engage with product management and business to drive agenda, set priorities, and deliver awesome product features to keep their platform ahead of market scenarios. They need professionals who can identify right open source tools to deliver product features by performing research, POC, or interacting with various open source platforms. Apart from which, they need somebody that can develop and implement best-in-class monitoring processes to enable data applications to meet the SLAs. So all these job descriptions boil down to some basic roles and responsibilities. One of the most important responsibilities of a data engineer is to design and build data warehouses. This is where all the raw data is collected, stored, and retrieved from. Without data warehouses, all the tasks that a data scientist or a data analyst does will become either too expensive or too large to scale. Let's look at this as the base of a building. The deeper the base goes into the ground, the taller the building will be without collapsing. Data warehousing is something like that for any data-driven business. As the system which data engineer builds is a critical one, so there are various factors or coefficients attached to it. Some of these coefficients include scalability, robustness, fault tolerance, etc. They need to ensure that the system which they are building can be scaled up with increasing number of data sources and can handle a huge amount of heterogeneous data without any failures. You can build a perfectly fine system, but it is of no use if it cannot be scaled up. If my data intake goes up and so do my data sources, I need my system to be able to handle it. Next, taking care of complete extract, transform, and load processes, or ETL as it is most commonly known. This is the step which a data engineer follows to build the data pipelines. ETL is essentially a blueprint for how the collected data is processed and transformed into data ready for analysis. Apart from this, all the responsibilities of a data scientist revolve around fulfilling the business requirements. After all, everything we are doing is according to a certain business acumen. They need to have business understanding so that they can understand business needs and build the complete system accordingly. A data engineer should always try to find new opportunities in finding new data sources where the data can be acquired and more insights could be derived. He or she should also look for new ways of exploring the data that is gathered from existing sources. A data engineer also needs to be optimizing performance and make the system reliable and improve data quality to build a stronger foundation for a superstructure. Apart from all this, one of the major responsibilities of a data engineer also includes performance tuning and making the whole system more and more efficient. There are two ways in which they can improve system performance. First, by optimizing each component, and next by tuning the complete system. Now that we've seen the responsibilities of a big data engineer, let's look at a few skills that are required to fulfill these. And we're going to follow the same format according to job descriptions. First up, we have Dell. Now the essential requirements for a big data engineer in Dell is supposed to be a master's engineering degree or a higher degree in computer science or IT, some experience with database development and data warehousing architecture, experience with Hadoop, Hive, Impala, Spark is also an added bonus, strong experience with managing teams of technical engineers in IT and e-commerce, experience in working with global environment with a remote team, leaders and peers, problem-solving mindset along with working in an agile environment, business experience allowing for a strong interconnection between analysis and solving of business problems, strong communication skills, which is a must, I think, these days for most of the jobs that you apply for, including the ability to convey analytic insights effectively to both IT and business audiences. Past experience leading teams to deliver against goals in an analytics or data environment is also required. Apart from all this, experience in having led teams to deliver multi-stakeholder projects in analytics is also required. Next, we have Ericsson. They've kept it pretty simple like their previous segment. From what I see, they mostly have kept it to technicalities, where they have education, which specifies BTech or MS in computer science engineering, data science, operations research, business analytics, and related fields. You need programming skills such as Java, Scala, and Python, data ingestion such as Scoop and Flume, data processing such as Hive and Spark, messaging systems such as Kafka and Storm, scheduling and workflows like Oozie and Azkaban, NoSQL databases like HBase, Cassandra, and MongoDB, and certain exposure to cloud deployment models. Moving on, let's talk about what Walmart searches for in its big data engineers. So according to Walmart, a big data engineer for their company needs to have a bachelor's degree and a 6+ years of experience or a master's degree with 4+ years of experience in computer science or a related field, expertise in big data ecosystems with deep experience in Java, Hadoop, Spark, Storm, Cassandra, or NoSQL, expertise in multiple parallel processing architectures, and knowledge of MPP engines such as Spark or Impala, experience in building scalable and highly available distributed systems in production, understanding of stream processing with expert knowledge on Kafka and either Spark streaming or Storm, experience with SOA, knowledge of graph database. Apart from this, they also require somebody who has a knowledge of software engineering with best practices and experience on implementing CI/CD, log aggregation, monitoring, and alerting for production system. So apart from these technical skills, you will also need to mention your interpersonal skills such as strong communication skills, leadership skills, managerial skills, problem solving, etc., which would prove your competency at the end. Now, everything that was mentioned in those 3 job descriptions basically boil down to these technical skill sets. First of all, we have operating systems and programming languages. Now, fundamentals of operating systems and programming languages are very important for a big data engineer. Operating system is required because a data engineer deals with various tools and packages which need to be installed on different operating systems, and then they need to know how to configure them. To fulfill all these responsibilities, a good knowledge of at least one OS is required. Industry-wide, various OSs are used such as Unix and Linux. Coming to programming languages, various programming languages can serve the same purpose, either for transforming data or writing a script in order to install a component. Programming languages are a very powerful weapon. Now, the knowledge of one programming language is enough, as the flavor changes, but the logic remains the same. But if you are a beginner, you can go ahead and learn Python due to its easy syntax and good community support. Apart from this, you can also go for R, which will have a steep learning curve in the beginning, but it is a language developed by statisticians and it is mostly used by analysts and data scientists to perform data analytics. Next, we have DBMS and SQL technologies. Now, majority of the data that are prominently used reside in databases and relational databases. So, knowledge of a database management system or a DBMS is required to define, construct, and manipulate relational databases. Database management systems are the crucial and important links in the creation as well as management of data. They are needed for effective running and management. It also helps the companies to transfer the data through entire systems. A DBMS stores, organizes, and manages a large amount of information within a single software app. Data engineers need to understand the database management system to manage data efficiently and allow users to perform multiple tasks with ease. This will help data engineers in improved data sharing, data security, access, and better data integration with minimized data inconsistencies. These are the fundamentals that data engineers should know to build a scalable, robust, and fault-tolerant system, as I had mentioned before. As a data engineer, you also need to know a relational database in depth. Knowledge on one RDBMS can be extended over the others. There are various RDBMSs that are used in the industry such as Oracle DB, MySQL, Microsoft SQL Server, SQLite, IBM DB2, etc. Data engineers must have the knowledge of one such database at least. Knowledge of a structured query language is also a must. It is used to structure, manipulate, and manage data that is stored in RDBMSs. As data engineers work closely with relational databases, they need to have a strong command on SQL. Next, we have ETL and data warehousing. Now, data warehousing is very important when it comes to managing a huge amount of data coming in from heterogeneous sources where you need to apply ETL or extract, transform, and load. Data warehouse is used for data analytics and reporting and is a very crucial part, not to mention the most time-taking part of business intelligence. It is very important for a big data engineer to master one data warehousing or ETL tool at least. After mastering one, it then becomes easy to learn new tools as the fundamentals remain the same. Informatica, ClickView, and Talend are very well-known tools used in the industry. Teradata and Tableau are also very widely used. Informatica and Talend Open Studio are data integration tools with ETL architecture. The major benefit of Talend is its support for big data frameworks. If you're new to data warehousing and ETL tools, I would recommend you start with Talend because after this, learning any data warehousing tool will become a piece of cake. Next, let's talk about the NoSQL databases. As the requirements of organizations have grown beyond structured data, so NoSQL databases were introduced to come to rescue. They used to store large volumes of structured, semi-structured, and unstructured data with quick iteration and agile structures as per application requirements. Some of the most prominently used databases are HBase, Cassandra, and MongoDB. Now, HBase is column-oriented NoSQL database on top of HDFS, which is good for scalable and distributed big data store. It is also great for applications with optimized read and range based scan. It provides consistency and partitioning out of CAP. Now, Cassandra is a highly scalable database with incremental scalability. The best part of Cassandra is minimal administration and no single point of failure. It is good for applications with fast and random reads and writes, and it provides available and partitioning out of consistency, availability, and partitioning. MongoDB is a document-oriented NoSQL database which is schema-free, which basically means your schema can evolve as your application grows. Great, isn't it? Which is why it gives a full index support for high performance and replication for fault tolerance. It has a master-slave sort of architecture and provides CP, which by now you must have guessed, consistency and partitioning out of CAP. And it is rigorously used by web apps and semi-structured data handling. With that, let's talk about our final skill required for a big data engineer, which is big data frameworks or Hadoop-based technologies. Now, with the rise of big data in the early 21st century, a new framework was born, and that is Hadoop. All thanks to Doug Cutting for introducing a framework which not only stores big data in a distributed manner, but also processes the data parallelly. Now, there are several tools in the Hadoop ecosystem which cater to different purposes, and the professionals belong to different backgrounds. Now, for a big data engineer, mastering big data tools is a definite must. Some of the tools you need to master are HDFS or Hadoop Distributed File System, which, as the name suggests, is a storage part of Hadoop which stores data in a distributed cluster. Being the foundation of Hadoop, knowledge of HDFS is a must to start working with Hadoop framework. Next, we have Yarn, which performs resource management by allocating resources to different applications and scheduling jobs. Yarn was introduced in Hadoop 2.x, with the introduction of which Hadoop became highly flexible, efficient, and scalable. Next, we have MapReduce, which is basically a parallel processing paradigm which allows data to be processed parallelly on top of distributed Hadoop storage. What I'm going to talk about next is Pig and Hive. So Hive is a data warehousing tool on top of HDFS, which caters professionals from SQL background to perform analytics on top of HDFS. Whereas Apache Pig is a high-level scripting language which is used for data transformation on top of Hadoop. Now, Hive is generally used for data analysis and to create reports, whereas the Pig is used by researchers for programming. Both are pretty easy to learn if you're familiar with structured query languages. Next in our list, we have Flume and Scoop. Now, Flume is a tool which is used to import unstructured data to HDFS, whereas Scoop is used to import and export both structured data from a relational database management system to HDFS. Next, and the penultimate tool is Zookeeper. Now, Zookeeper acts as a coordinator amongst the distributed services running in the Hadoop environment. It helps in configuration management and synchronizing services. And finally, we have Oozie. Oozie is a scheduler which binds multiple logical jobs together and helps in accomplishing a complete task. Next, let's talk a little bit about a real-time processing framework such as Apache Spark. Real-time processing with quick actions is the need of hour. Either it's a credit card fraud detection system or a recommendation system. Each and every one of them needs real-time processing. And it is very important for a data engineer to have the knowledge of a real-time processing framework. Now imagine, if I wanted to order a red dress today and my recommendation system recommends it to me next month, will it be of any use to me? No, right? Which is why we need real-time processing today. And Apache Spark is one such distributed real-time processing framework which is used in the industry rigorously. It can be easily integrated with Hadoop leveraging HDFS. Now, the road to being a big data engineer is definitely going to be a long one, and we at Edureka want to help you with it. Here you can learn at your own pace, at your own time, from a location of your choice. But the Edureka experience is much more than just this. This caters to every single aspect of a big data engineer skill development, and we also have a specially curated Big Data Masters program which helps you gain expertise in tools present in the big data ecosystem. Your road to learning is going to look something like this. You will initially start with Hadoop framework, where you will first master HDFS, Yarn, and MapReduce. And moving ahead, you'll gain expertise in Hadoop ecosystem tools such as Hive, Pig, Flume, Scoop, HBase, Oozie, and Zookeeper. Apart from this, you'll also master the prominently used NoSQL database, that is Cassandra. Next, you will learn ETL tools that can be used to integrate big data tools such as Talend. Then, moving ahead, you'll master a real-time processing framework, which is Apache Hadoop. At last, you'll master Apache Kafka, which is a distributed messaging and streaming platform. After completing all these courses, you'll be working on a capstone project which will give you a near real-world experience on how a big data engineer works, and it'll help you in understanding problems from the perspective of a big data engineer. At the end of the master's program, you will be awarded with a certificate, and what could be better than that? So don't simply learn big data, master it with Edureka.